Alright, we got us another little machining project here in the shop. This is another one of those that's been backlogged for months and months. I believe I've had this since last year, or late last year. And what this is, I believe he says this is a, like maybe a ball joint tool. I know you use it on automotive. And it's basically like a press, a press tool where you unscrew this, and I believe it pops the ball joints apart. I'm not sure of the exact application, but I know it's for that type of application right there. And the problem is that one's bent. And I believe he says this is a pretty old tool. He's had it for quite a while, and asked me if I could help him out fix it. This is for Mr. Sosta that I've done several projects for in the past. I did a few projects for him way early in the channel, just different things that he needed help with. So this is just a fun little project doing the shop. And I think what we'll do is take a piece of drill rod right here. This is a piece of 1¼ inch drill rod, 01 oil hardening, and we'll go ahead and machine one of these. You have a counterbore on one side with a 3/4 counterbore. It looks like maybe 3/16 deep. You got an 1 1/8" hex machined on it, and we're going to have some 3/4 fine threads machined on one end right here. The diameter of the drill rod is a little bit undersized from what your corner to corner dimension is on this, but I think it'll be fine. It's about 40,000 small, but I think it'll still work. You can still put a wrench on it and be able to twist it. So we'll go ahead and go to the Monarch and turn it and thread it and cut it off, and then we'll go to the collet chuck over here on the Victor and hold it and go in there and face it and do our counterbore, and then we'll do a heat treat and a nail for it. Alright, we did a preset on the jaws. I'm going to go ahead and slide the material up in the chuck here. And we'll probably go ahead and just part this sucker off, so we'll leave us a little bit of wiggle room there. That looks like that's going to be good enough. All right, I think that's close enough right there. First thing we'll do is just face the end off clean and check the center here. Got a 2.5 inch shoulder length there, and we got our dial set. See how this cuts that drill rod there, this insert. Feed here. Oh yeah. Doing a nice job there too. It's about a 10,000 feed rate there. 10,500 feed rate. I think we're going to go ahead and use the coolant on this one. We'll use it for our turning here, and then we'll try it for our threading also. So that was 3 cuts at 1/8 the pass, so I'm down to my final cut, and what we're going to do is we'll just take it one shot here. So that's 117 plus 5. So we're going to take 122 thousandths to bring it down to 3/4, 0.745. Now, I am going to leave a radius in the corner, so I'm going to stop that tool about 1/8 before I get there, and then I'm going to use, I got this parting blade right here that I've got a nice radius machined in, not machined, but honed into the corner, and or on the end of it, we'll use that to radius our corner. So dial in 122 right here. And take a finished cut. Okay. Okay, 745, that's where we want it. Just so that it's a little easier to see this off, I might use a little bit of this cutting oil here. We got most of it blended there, so I'll come down here and just touch this finished diameter. Yeah, there we go. I'm going to use that top notch threading insert to thread this thing. We're going to go ahead and use this new edge tool again that I showed last week. Alright, so that's a little high. That ain't too bad. Maybe just a touch high. Okay, we're going to go ahead and touch off on our compound. I got my cross slide set to 0 here, and we'll go ahead and start threading. All right, 0. We'll go ahead and make us a scratch pass and make sure we're on it. I'm going to use the cutting oil instead of flood coolant. That way I can see it down here. I'm just going to stop about a 1/4 inch from the end. Check, make sure we're cutting 16, and that looks right. Okay. I don't know if that insert's gonna cut perfectly smooth. It looks like it's leaving some edges on it. So that's a 16 pitch. That means that I can engage this lead screw anywhere I want to. any line. I don't even have to look at it. It's just it's good habit to look at it, I guess. So I just kind of drop it in wherever I want. Looks like I hit a good fit there. I left it a little shy. We're maybe about 7,000 shy on the dial, but that's actually fitting right where it needs to. It's not tight, it's got a little bit of looseness to it. Yeah, that'll work good right there. I'll use that threading tool to go ahead and cut this bevel on that side right there. That always looks really good at a 30-degree angle. All right, we're gonna go ahead and part this sucker off. We got a little past 3/4 on the thickness there, and we'll face it. I'm gonna try the coolant here, but I don't know if it's gonna work. The chuck's probably gonna try to sling it. It's trying to sling it. Trying to keep it down to a minimum here. There we go. All right, so we'll just come over here and we'll use our 3/4 collet from the last job that we did. I want just enough room where I can come in here with my calipers and measure that, so that looks good right about there. We'll see about what we got to take off. So I'm exactly 13/16 now, so we got a 1/16 to remove off of it. So we're going to make that 3/4 inch counterbore there, and it's It's about 3/16 deep. I done measured it with the calipers. I'm just going to call it 3/16. So it's not an accurate hole. It's just a counterbore for a part to fit down in and keep it centered. So we're going to start with a 1/2 inch end mill here and plunge it in there. Then I'll finish it out with a 3/4 end mill. Now this isn't really the proper way to use an end mill in a drill chuck, but for things like this it works. When you're trying to make a shallow flat bottom, or if you just want to flatten out the bottom of a hole, they work pretty good for that. Just take it easy and don't get in a hurry and jam it in there. Alright, that was the bottom right there. Come in here and just break that edge. So we're on the do-all mill. We're going to go ahead and get the hex machined on this bowl here that we're making. And we're going to use the super spacer this time, but we're also going to use our 5C collet block. And the reason why is because you don't really want to chuck the threads. You're probably going to damage the threads if you just chuck that straight up. You could, if you don't have a collet block and you needed to do something like this, another way is to make like a split bushing that screws down on here that's split, so that you can stick it in there and tighten the jaws and it'll squeeze onto the threads. That's just another good way to do it. But we're going to use our collet block. So we've got our 3/4 collet, and the first thing I'm going to do, I want to make sure that it's sticking out enough that I have adequate clearance for the end mill, whatever cutter that we're going to use, and try to keep it from sliding out. I'm just going to snug that up there, and we're going to go ahead and tighten the spanner nut here on the end. I want to make sure that it's German, the way the Germans do it, good and tight. We're going to put a little bit of that A-bomb torque on it right there. Okay. Now we've got it fixed up in there. We're going to go ahead and we'll flip it around and get it squared up on our jaws. Make sure that it's square and it's clamped squarely. All right, and we're ready to roll. What I like to do is use the top of the spacer here as a reference point for 0. Even though my marker is around here, you just want to start off at a reference point. So I'll rotate this around until it locks in on 0. So just looking down, this little oiler button, that's what I reference as a 0 mark. So you can see our 0 there, and that's where we're going to line it up every time and click it in. So we'll make a cut and rotate it 60 degrees and make another cut, and just keep doing that. Inch and a quarter, it's right on it. So we'll take a 16th cut. We're going to use this little carbide end mill, or carbide tipped end mill anyway, and see how it does. Alright, that's our 0. We'll bring our knee up to 16. Way too far. Okay. So we'll go ahead and flip it 180. I'm looking at the top. We're going to drop it in on 180. Too far. And then we'll mic it after we make this cut. Trying to drag a little bit. Must be that tool. Alright, saying that we need 3/1000ths. I'm just going to go ahead and bring it up another 2 and we'll recut them. Alright, so we'll go to 240 degrees. Next one will be 300. Back to 0, which will be 360. We'll go ahead and cut that couple thousandths here. And we got a couple more. So now we're at 60 degrees. $120, and it looks like our last cut. Go ahead and give it another check and see if it corrected itself. Oh yeah. 1/1000ths under. We're at 1 inch 124. Let me go grab an 1 1/8 wrench and make sure that's going to fit good. We've got our Craftsman 1 1/8 wrench, and it fits just like it should, just like a mechanic's going to want it to. Okay, there we go. I need to do a little bit of deburring. I think I need to go back to the lathe and hit that chamfer one more time and get rid of them sharp edges. All right, we're gonna go ahead and heat this up, and I'm gonna heat it up to a temperature where it's kind of a glow and a warm red, and then I'll use the pliers and we'll grab it and we'll drop it in the oil right here. And I'm gonna use my fume extractor to suck the fumes out as we're doing this, so it'll be a little noisy probably, but that's what we got the fume extractor for. getting most of it. I had a little bit try to fan out from around it, but go ahead and we'll bring it on down here right on top of it and let the fumes go up in it. So we're gonna let that cool down just a little bit. So the part's cooled down enough where I can actually hold on to it. So it's still pretty warm. I don't want to just hold on to it, but you want to get it to around 120 degrees, I think, around 125, 130 degrees. So I want to go over there and wire brush it and get the black scale off of it, kind of polish it up again, and then we got to temper it. All right, so we've got it wire brushed, kind of cleaned up. Still got some warmth to it there, and it's really hard right now, as some people like to call it, like glass hard. So we want to temper it down a little bit. So we're going to shoot for a range of 400 to 600 degrees. It should turn like a straw brownish color, and then I'll just let it sit, and hopefully that'll bring it back to the temper that it needs for strength, where it's not so brittle. Probably well within the range that we're looking for right there. Not quite the color that I was speaking about, but that should be it. I need to get some other temp sticks. That's a 350 temp stick right there. I wish I had some other ones, or a temp gun. And I'd like to get me a set of those files that you use to check Rockwell hardness. I don't have any of those either, but I'm just going to let that sit there and cool, and just come down to a complete cool where I can hold it, and we'll be finished up with this job. All right, so we let her cool down to room temp now. I can pick it up. I really like the way the coloring has turned out on it. Kind of a pretty color. So as far as the tempering temperature there, I believe I got it somewhere between 500 and 600 degrees based off of the color charts online. This could be considered, I think, a brown purple up to a dark purple. So it's going to be between that 500 and 600 temp range. So I feel that should be adequate. Again, this is it's a tool that you use for pressing ball joints. Part of the ball joint just presses against that, and you unscrew this to pop it out. I believe that's going to work for them. There it is compared to the old one. So there we go. There's another job done. We'll see you on the next one.